Okay, so everybody can see the screen. This is the homework 1. Am I right? Good. Let's start. So first problem is from chapter 1, and we need to solve an equation for theta. So we need to find all of the answers, and they should be in the radians. So this is the screen. And we can see this equation. We need to solve this to find the theta. So what you need to do is to convert these two into cosines. We previously studied these parts and solved many questions. So we can move to the answer. So this is the equation that we have. So we need to convert this to cosine. This square root of 2 comes out of this real part, and we will have square root of 2 times cosine of theta minus pi over 4. So it equals to 1 minus square root of 2 times cosine of theta plus pi over 4. So this is the usual things that we did before also. Then we will move this term to another side and factor square root of 2 from two terms. This gives us this equation. So as you can see here, we have a equation that we can use trigonometric identities to simplify these two terms. So as you can see here, exactly phi is replaced with pi over 4. So we can say that this term equals to 2 times cosine of theta times cosine of phi. So we can replace it, and the equation will become like this: 2 times square root of 2 times cosine of theta times cosine of pi over 4 equals to 1. So after simplifications, we will have cosine of theta equals to 1 over 2, and we can find theta equals to 2 kp plus minus pi over 3. So you can replace with different case. If it goes to 0, we will have plus minus pi over 3. If it is 1, then we will have theta equals to 5 pi over 3 and 7 pi over 3. So this is the general final answer that we have here, that you need to write as a final answer, and it is in radian. So this is the correct final answer that we can achieve. Okay, do you have any questions regarding the first question? This was from chapter 1. So if we don't have any questions, we can go to the next question. In the second question, we have a signal which is in time continuous. So periodic signal x of t with a period of t equals to 4 is described over one period from 0 to 4 by the equation below. So we have this equation. Between 0 to 2, we will have 0, and between 2 and 4, this is t minus 2 to the power of 2. this signal can be represented by the Fourier series, which is valid for all the time. So we want to write Fourier series for the signal from the chapter 2. This question is from chapter 2. So in the first part, it asks sketch a periodic function x of t. So this is for one period. We need to sketch for several periods. So it didn't ask us in a specific range. So we can sketch just 3 periods, and we can put 3 dots from the end and from 2 sides, I mean. So this is the easiest part. The sketch is like this. From the 0 to 4 is this signal. From 0 to 2 is 0, and after that we will have t minus 2 to the power of 2. Then we need to repeat this periodicity from 0 to 4. So you need to just shift 4 units. So it starts from 4 to 8, and also from this side, minus 4 to 0. So 3 periods are enough for the first part. So if you draw and sketch more, it is possible, but at least we need 3. Okay. So let's move on to the next part. So find the AK coefficients. So we need to find these coefficients. So we have a definition for that, as you know. We need to write that one here. As you can see here, AK equals to 1 over period of signal times integral from 0 to t0 of x of t times e to the power of minus j times 2 pi over t0 times kt dt. So as you can see, t0 equals to 4. We replace 4 here, and we will have 1 over 4 times integral from 0 to 4 for this signal, which is x of t times e to the power of minus j times pi over 2 kt dt. What we need to do here is look at the graph. So as you can see here, from 0 to 2, we will have 0. So the answer from 0 to 2 should be 0, because here x of t is 0. So we break 0 to 4 into 2 parts, 2 integrals. First integral is from 0 to 2, and another is from 2 to 4. For the first one, from 0 to 2 is 0, times this one, which definitely is 0. And for another one, we will have the equation, which is in the answer, in the questions. We'll have t minus 2 to the power of 2. So we need to replace it here, and times this term. So we need to just calculate this one. So you need to take the integral of this function, which includes the multiplication of 2 functions. So you know how to integral. After taking the integral of this function, we will have these terms here. So this is the these are the terms after integral, and we need to put one time 2, another one 4, and subtract from each other. So we did it here. First we put 4. Actually, we put 4 here. Then another one is replacing 2 into this term. Then we need to subtract, and we give this final answer. Since we have minus 1 to the power of k, we can divide into two sections. When k is odd, when k is even. Therefore, uh, we can simplify this equation. Uh, yes, actually, you need to. Okay, we have a question here, which we need to show details of the calculations. So, what you need to do for the integration is write this one in one side. So I cannot. Yeah, I can. So we have several methods for calculating this integral. One is to uh, doing this. I use this method over 2kt. Okay, you need to uh, take the derivative of this function and integral of this function. So here we will have 2 times t minus 2. Then another one is 2t minus 4, which the derivation of this one will be 2, and other one should be 0. You need to write as this to achieve 0. Then you need to take the integral of this function. It has some coefficients. I don't want to do it because we lose time. So you need to do the integration here, here, and here. For example, we have something like here, something like here, here. Okay. What you need to do is multiply these functions. Sorry. Okay. Multiply these. This is with positive sign. This is negative and positive. Then do the summation for that. So that would be this term times this term with plus sign minus multiplication of this with this one and plus 2 multiplies by this. So this is the method that I use, but you can find another solutions for doing this integration, which is uh, another one. Maybe I can do something like this. So okay, so you need to um, convert one parameter to another. I mean, assuming that t minus 2 to the power of 2 goes to s, then do the derivative of two sides and find ds and also dt, substitute with the terms and find it. But usually I use this method. You can find another methods to do it. Is it clear? Okay. Okay. So we can continue here. So how can I? Here. Okay, good. So we receive this function as two sections. So k is odd. So we will have this simplified equation. When k is even, we will have this term. As you can see, it's very simplified in comparison with this one. So this is ak, which is Fourier coefficients that we found. Okay, part C says compare the area of curve in one period and DC coefficient, which is A0 value. So as you can see here, let me move to the answer key here. In one period, we will have, um, okay, sorry. Uh, the area under the curve, which means here. So if I plot this line here, we have this area under the curve. So this area should be calculated. Actually, if it was just a straight line, so we could just do the math and find the area below the curve. But we here need to calculate it because this is not easy to calculate with high. So here in part C, we need to find the area of curve, which is here. Actually, from 0 to 2 is 0, but after 2, we have area. So from 2 to 4, we do the integration, and we take the integral from 2 to 4 for this function, which is t minus 2 to the power of 2 dt, which equals to 8 over 3. So this is the area of curve. And it says calculate A0. For A0, we have also this equation. Actually, this is 1 over T0 times integration from 0 to T0. So T0 is 4. We replace of T, then we will have final answer as 2 over 3. Okay. So this is 2 over 3. So what is the we need to make a comparison. So as you can see here, the area of curve is 4 times this A0. So we can write as this. Area of curve in one period equals to A0 times T0. Next time, when you want to calculate A0, you don't need to write this integral. You can do something like this. Calculate the area of curve in one period if it is easy to calculate by eye, which, for example, have a certain shape. So you can do this calculation, area of the curve, then divided by t0, which is this period of signal. So it gives us a0, which is DC coefficient. In the next part, it says if y of t equals to derivative of x of t, and bk is the Fourier series of y of t, find b2. Okay, here we didn't want to solve with the integration. So we need to solve it with some features that Fourier series has. As you know, for this signal, which is derivative of x of t, we can write bk as jk times pi over 2 times ak. We have this. You studied before, I think. So as you can see here, b2 equals to j pi t, and k is 2, so cancel with 2. So we will have a2. So we found ak before. So here we have. So we need to find a2. 2. So we can find b2 as this one. So there is no need to calculate from coefficients from the Fourier series. This is the answer for part D, for second question, which was from chapter 2. So If you have any questions, you can ask. Actually, it was from chapter 3, so let me correct myself. It is from chapter 3, which are Fourier series. And first one was from chapter 2, sinusoidals. So do you have any questions regarding this question, second question? Okay, if not, we can proceed more to next question. Number 3. We have ideal C to D and D to C converter. So this is the image that we have. Suppose that discrete time signal x of n is this. So this is continuous time. So discrete time, then we will have continuous time t, and output is y of t. So we have sampling rate fs, which is 1 over ts. If the sampling rate is 500 samples per second, determine two different continuous time signals that could have been inputs to the system. Okay, so we need to find two signals for this one. Let me move to problem 3. So our original signal is x of t here. We have sampling rate of 500. So to write x of n, we will have we need to replace t with n over fs. So we have this equation here. Then we need to replace it. Then after that, we can find omega naught as 130 pi. And phi equals to minus pi over 6. So folded radius is fs minus fo, which is f0 equals to fs minus omega 0 over 2 pi. So at the end, we will have 435 hertz as a frequency. So we need to replace it as here. As you can see, this is here. So t equals to n over fs. Then we need to do the calculations here. At the end, what remains is this signal. So f0 over fs. So f0 is 65, and we know that fs it was 500. So phi also equals to a positive with positive sign pi over 6. So we have two signals, as you can see. One of them is here, and another one we can see as here. The part B, we have signal as here. It is shown here. So it says that we need to determine a formula for y of t. But this time, fs goes to 1000 for both of the converters. So we can write exponentials and do the calculations. We need to write as cosines. So in part B, this would be the signal in terms of cosines. This is 16, this is 4 as coefficients. As you can see, we need to double this one, which is 16, and double this one, which is 4. We have one signal, and another signal is this one in the 200 and 700 frequencies. So we put 200 and 700 here, and coefficients as 16 and 4. Then we will divide by 1000 because the part B, the sampling rate is 1000. So we will have this equation. After that, we have this one. So for finding this one, as you can see, again, we need to divide by 1 over 1000, which gives us 200 and 300. Actually, this is not 200, 300, because when we do the subtraction, we will have minus 3 over 10. This was from chapter 4, which was sampling. Let me see. Yeah, we had 2 parts. Do you have any questions regarding this question? If not, we can move to the next question. In the problem 4, a signal is given as below. So we have a signal as this. Is this signal periodic? If so, what is the period of the signal? So we need to investigate whether it is periodic or not. After that, we need to write the periodicity if it is periodic. So first, please note that this is 3 pi. So what you need to do is write as 2 pi multiply by 1.5. So 1.5 should be multiplied by 500, which gives us 750. Similarly, here we should write 2 pi times 1500. So please pay attention to the signal. So we have 750 and 1000 because the LCD of this one is 750, so that would be periodic. So the periodicity would be 1 over 750. So let me move to the answer key here. Yeah. So for part 1, it was periodic. We didn't ask the why, but you can write the reason, and t equals to 1 over 750. So this is the periodicity of the signal. In part B, it says that plot the two-sided spectrum of the signal. What we need to do in this part is writing the equation in the form of exponentials. So we write as exponential. We have 2 cosines. We need to write as these. X of t equals to 3 plus 1 over 2 times e to the power of j 2 pi 750t plus 1 over 2 times e to the power of minus j 2 pi 750t times another cosine, which is 1 over 2 times e to the power of j 2 pi 1500t plus 1 over 2 times e to the power of minus j 2 pi 1500t. So this is the form of exponential we need to write because we need to plot the spectrum. We need to plot two-sided spectrum. So here we need to simplify this equation. So we multiply these 2 terms inside this parentheses. So we will have these terms, which we have 6 terms. Here we will plot these. You need to pay attention to frequencies, which is in the x-axis, and y-axis. Y-axis is for amplitude, and x-axis is for frequency. So the first term is 3 over 2 in the frequency of 1500. So we have here, and it is 3 over 2 here. In the negative 1500 frequency, we will have 3/2 again, and all of them are positive, and we will do as this one. So this is the two-sided spectrum we plotted here. You can see the frequencies and the amplitude that are important for this plot. So what relation should be sampling rate satisfy so that y of t equals to x of t in the figure 1? So what was this figure 1? Here. So as you can see here and as you can guess, sampling rate should be twice the highest frequency that we have in the spectrum. So the highest frequency in this spectrum is 2250. So this is the highest frequency. 2 times this one should be the sampling rate, and it should be at least this value. So it should be more than 2 times 2250 hertz. Generally, it should be more than 4500 hertz. If this situation is satisfied, so we will have y of t equals to x of t here. So this was the answer for question 4. If you have any question, you can ask. So we don't have any questions, so we can continue, I think. So let's move to question 5. Feeder coefficients on FIR system are -2, 2, 4, and 6. Determine the y of n if x of n is this one. So our input signal is -1 for 3k numbers, 0 for 3k plus 1, and 1 for 3k plus 2. So if we put k as 0, so that would be 0, 1, 2. And it repeats. So 0, 1, 2, 3, 4, 5, and goes on.